Okay, and the last topic that we need to talk about here within this very long and difficult section of 6.2 is something called the average value of a function. And to be honest with you, this section, or this topic, really doesn't need to be included in this section right here. And I'm not entirely sure why the author put it here. It does have to do with area underneath a curve, but now that we're talking about volume, that doesn't really seem to apply very well here at all. But it's something quick and relatively easy. We're going to talk about it and do one example and then move on. So, as you can see here in this big red box, there's a formula for the average value, but I should be specific, the average value of a function called f of x, there I go doing that again, on a particular closed interval here from a to b. And the formula for that is written right over here. It is 1 over b minus a multiplied by, there could be a big blue dot right there, although that's implied, multiplied by the definite integral from a to b of f of x taken with respect to x. In essence, guys, what we're talking about here is that the average value of a function really means the average y value of a function. And when we're talking about the y value of a function, we're talking about its height. So this formula allows us to figure out the average height or the average y value of a function by doing the following. The integral here from a to b of f of x dx measures the net area between the curve and the x-axis. And then this quantity right here of b minus a represents the width of your region. So we're taking 1 over the width multiplied by area. And if you were to think about something nice and simple like a rectangle, if I were to tell you, let's just go with something easy, that the area of this rectangle was 32 square meters, and that the width of this rectangle here were 8 meters, and I were to ask you guys, hey, what's the value of h? Well, every one of you would look at this real quickly and tell me that the answer is 4. But essentially now, if we were to follow this formula, that's what we're doing in a slightly more technical way. Height is equal to 1 over the width, which is 8, multiplied by the area of that rectangle, which is 32. 1 over 8 times 32 is, of course, the same thing as 32 divided by 8, and that's going to get you 4. And if we wanted to throw units in there, that was 32 square meters, but the width was 8 meters. So you're effectively taking square meters divided by meters and getting meters now for the average height of this figure. So that is really what this formula right here is finding, everybody, but for regions that are far more complicated than something like a rectangle. And of course, for rectangles, triangles, trapezoids, even circles, we don't need calculus for this. We have geometry, but geometry is limited. It can't do that much for us, and so calculus is necessary for us to do that. If you take a look at this little graph that I've drawn over here on the right, this was just an example that I decided to throw in at some point. I've given you a weird piecewise function. Okay, it starts off at a y value of 4, drops down to a y value of 1, then jumps back up for a y value of 3. So my question for you guys is, with this y value of this function jumping all over from 4 and then down to 1 and then down to 3, what is the average y value of this function? Well, I'm pretty sure that it's somewhere in between the maximum value of 4 and the minimum value of 1, but I don't know exactly where it is. So let's see if we can't figure out this plan right here, and I think I'm going to do this in purple right underneath this problem. This isn't really the example that I wanted to do, but while I'm here, I might as well figure it out. So the average value of this function is going to be 1 over b minus a. Well, this region that we have here ends over here on the right at 4 and begins over here at 0. So that's going to be a 1 over 4 minus 0 multiplied by the integral now from 0 to 4 of whatever this function is, which I didn't name, so I'm just going to generically call f of x taken with respect to x. And let me clear myself a little more room here just by sliding all of that down a ways. Okay, and what can we do here now, guys? So average value of this piecewise function is going to be 1/4 multiplied by, and let's not forget a fundamental idea from back in chapter 5, everybody. You can use a definite integral to find area. But in some cases, you're better off using area to find the value of an integral. Now, since I didn't give you a definition for this function, we're going to go ahead and just break it up into 3 chunks. There's one of them, there's a second, and this rectangle here is the third chunk. So let's see what we've got. The first big rectangle is 1 by 4, so it has an area of 4. The second rectangle is 2 by 1. It has an area of 2. And the third rectangle is 1 by 3. It's got an area of 3. So adding those together, 4 plus 2 plus 3, is going to get us 9. And 1/4 of 9 is going to get us 2 1/4 for the average value of that function. Ta-da! That's the answer. Great, Mr. Fontana. What does it actually show us? Well, if we were to draw the line y equals 2 1/4, that would be a horizontal line right about here going right down this graph looking here. And essentially, guys, here's what we see. There are parts of this graph that go up above that line that I just drew, like this rectangle right here and this rectangle right here. Then there are areas here below the red line that are not filled in by that graph. So I'm going to switch colors and I'm going to make that a lovely shade of, I don't know, I've done blue, I've done purple, I haven't done any green here yet. So we'll do that in green here, and you've got this area then right here that's not covered. Essentially, guys, if we were to chop off this region and throw them in here, they would fill up this missing space. Okay, that's one way to look at it. Another way to look at it here would be this, and this is maybe easier than what I just said before. If we were to think, let me go back to red here, if we were to think about a rectangle that had the same width as this original graph from 0 to 4, but only had a height now of 2 1/4, this red rectangle that I have just drawn, here, there you go, that red rectangle has the exact same area as the original function that I'm shading now in blue. This one, and this one, and this one all put together. So we're basically taking a weird, irregular region and creating a rectangle, much nicer, that has the same area. So that's effectively what average value is telling you. It's a pretty quick and pretty simple concept, guys. So let's knock out one example and let's be done with this really long section. So find the average value of, and here we go. Now instead of a graph, we have an explicit definition of the function on an interval here from 1 to 4. So average value is equal to 1 over, we said b minus a, so that is going to be a 4 minus 1, multiplied by the definite integral from a to b, 1 to 4, of x cubed taken with respect to x. It's really not that hard to calculate, everybody. This is going to be a 1/3 multiplied by antiderivative of x cubed is going to be a 1/4 x to the 4th evaluated from 1 to 4. So I'll put the 1/3 and the 1/4 together to make a 1/12, and now in brackets, oh boy, 4 to the 4th, 16 squared is going to be 256, minus 1 to the 4th, that's a little easier, that's 1, and we're going to end up with an answer here, just lovely, oops, nope, not that, of, oh man, really? All right. Here we go, Fontana, of 255 all over 12. Okay, so that's the answer. It's not that hard to come up with. What's a little bit harder to do is figure out the meaning of that answer. Let me go ahead and just convert that real quick. I don't know, 12 goes into 240 20 times, so 21 times 12 would be 252, and 3/12 or 1/4. So the answer we just came up with is 21 1/4. And let's see if we can explain what's happening here, guys. And I tell you what, I'm going to see if I can do that on my calculator here. Essentially, yeah, let's see if we can play around with this. Let's go here. I'm going to go to a calculator page, which I don't believe I have open yet. So I'm going to add a calculator. And no, not a calculator. Dummy, I wanted to add a graph. I'm struggling here, kids. All right, here, let's add a graph page. And we're going to graph the function y is equal to x to the third power. And hopefully not surprising, we know what that looks like. However, we're going to be changing some things around. We were looking at an interval here from 1 to 4. All right, so I tell you what I want to do. I'm going to go to menu right here. I'm going to go to window or zoom, and I'm going to manually change my window settings. My X minimum, I'm going to keep that at 0. My X maximum only needs to go to 4. There you go. And for X scale, I'm not going to worry about that. My minimum Y value, well, since I started this thing at an X value of 0, my minimum Y value is going to be 0 as well. And let's see, my maximum Y value, I went to an X max of 4. 4 to the third power, then, everybody, is going to be 64. So I'll go ahead and put that in here. And when I hit enter and OK, that is effectively the graph that we are looking at. Now, one of the things I haven't really shown you now, guys, is if you hit menu and you go to, let's take a look here, Analyze Graph, one of the things it'll do for us, everybody, is an integral. And the lower bound, shoot, for you guys, you can just go ahead and type in a 1 on your calculator. And I don't know that I can do that right here. Can I drag this? I can, but I don't ever see its coordinate right there. Well, shoot. That is not quite what I wanted to do right there. I wonder if I could have zoomed out just a little bit on this, if that would have gone better. You guys should just type in a 1, hit enter, then a 4, hit enter, and you should get that magic number that we were looking for here. And I don't think that I can do that here, or at least I don't know how. So let me see. Can I get out of here somehow? There's no escape key either. Let's get rid of that. Let's go here. Yeah, that's not really showing me what I wanted. Give me a second, guys. I might be able to fix this, or I might just be wasting everybody's time. Let me go here and make this a little bit smaller. Let me have this go to a -1, and my Y minimum, I'm going to have to take that to a -1 as well. Maybe seeing a little more of the graph, maybe this will work better for me. So let me try this one more time. We're going to go to Analyze Graph. And I am going to do an integral here, and my lower bound, no, it's still not telling me what the x-coordinate is. I can guess 0.4, 0.6, 0.8, and 1 would be right about there, and my upper bound would be all the way over here at 4. Okay, and that number I came up with here, 63.5814, is, where are we here, everybody? Okay, that didn't show up here at all. What that actually is roughly, though, guys, is the value of this integral right here. We then divided that number by 3. That's the 1/3 here. And that, what was it, 63 point whatever divided by 3. Yeah, that gets us the 21 that we were looking for. The other thing I wanted to show you is that now we can go ahead and we can graph another line on this function here, or on this graph. And I'm actually not sure how to do that. Probably one of these buttons here on the left. No, I don't want to do that. Okay, Mr. Fontana. Oh, yeah, double tap. There we go. We think that our average value here is 21 1/4. So I'm going to graph 21.25 as a constant function and hit enter. Okay, so there's the constant function. And now, if we were to analyze the integral now of that red function, I've got to tell it to pick that one. The lower bound, we're going to try to start right here at 1 yet again. And the upper bound, once again, we're going to take all the way over here to 4. Okay, and it didn't work out perfectly, everybody, because I'm trying to graph this by hand. But what you can see here, I hope, everybody, is that the area of the rectangle underneath the red line should be equal to the area of what we have underneath the blue curve from 1 to 4. And I wish you didn't see this whole region kind of up above and to the left, because that's kind of ruining my point. But anyway, that's how you do average value, guys. Not anything too complicated, and I don't think that's going to cause you too much trouble here at the end of 6.2.